Hello, welcome back to episode 14 of SAS From Scratch. This time it's episode 14C, and we are finally going to wrap up chapter 14 in the SAS base prep guide. So today is all about numeric functions. Now I put this disclaimer at the front of every single episode 14 video that we did, whether it was the date functions or the string functions that we looked at last time. But we are going through only a small, very small subset of functions that are built into SAS. And that is simply for the purposes to stick within the scope of what you have for the base exam. The number of functions that SAS has built in is enormous. And you can go and look at the online help and documentation, and you'll see that there's hundreds, if not thousands, of functions available in the default toolbox that SAS has. And the reason why I stress this is because you're not going to be able to download extra packages and libraries and all kinds of things as easily as you would normally do with, for example, R or Python or a different language. So if you do have need of a particular function and you might think it doesn't exist, it probably does exist and you've just not heard of it, go and check the documentation online. But let's get started with today's slides. And I have a bunch of functions in the table format, and the reason for that is we probably don't need to go through all of these one by one. I might choose to do that anyway, but let's see. I think if you're familiar with some of these functions from another language, it will make a lot of sense. If you've done them in a math class or a math course, statistics course, it's going to also make a lot of sense. So the first function we're going to look at is the ceiling function, which returns the smallest integer greater than the argument. So that's rounding up. So for example, and I do actually want to look at that. This is what we'll work on later. So we've got like a data set with a bunch of numbers and or scores or whatever you want to call it in here. And I've already set up our program for us. But before we get to that, let's get a quick, let's just call it test. And we'll do something like say, okay, well, x is 7.0 and y is 7.1. So if we say x CEIL is ceiling of x, and we say y CEIL is the ceiling of y, what we're expecting is to round up, but it's going to be the closest integer. So if you've got x equals 7, that's already at the closest integer and it's not going to round up. So that stays 7. However, y being 7.1 will round up to 8. The thing to bear in mind here is the difference between just normal rounding and rounding up, which is going to be that if you use the normal round function, this would have been rounded down to 7 because it's less than 7.5. But with the ceiling function, if you've got a decimal, it'll immediately increment to the next integer. Now your floor function works pretty similarly to this. Now if I didn't give it such specific names, this would have been a lot easier. If we run this, the floor of 7 stays 7. We're already at the closest integer. For 7.9, if we floor, it goes to 7. So if we would have done a normal rounding function, it would have gone to 8 because it's larger than 7.5. But because we're flooring, we're essentially truncating this decimal. That's the ceiling and floor function. So ceiling rounds up, floor rounds down. If you use the int function, as you can see here, pretty straightforward. it gives you back only the integer part of a numeric argument, and it discards the decimal, similar to what a truncation function might do. And then we can also get the absolute value of a numeric argument. So the absolute value of 3 is 3. The absolute value of -3 is +3. This is something that you would have covered in math class before. That's the first batch of functions. So far it's straightforward, I think. Let's look at, for example, the min, max, and mean functions here. Now keep in mind that these functions are always going to be row-based. So we're not, as we would have done in R, for example, getting the minimum of a column, but we're getting the minimum across a range of columns, but within one row. So I want to jump to the code pretty soon, but I want you to just take note of this of keyword that I've got in here for these functions as well. So let's look at min, max, and mean, and then we'll talk about rounding. So I'm going to close this program for now, program 1, and I'm going to jump to episode 14 c.sas. As you can see, I've mapped the library, and I'm just reading in this numbers data set that we've got here. I'm going to open that up, and notice we've just got 5 lines, line 1, line 2, line 3, 4, and 5, and maybe these could have been student 1, 2, 3, 4, and 5, and maybe these are assignments and exam scores or whatever it might be. And so, for example, if you wanted to get the minimum score from A1 to A3, so let's say min score A, that gives you, or let's just say min A, that's going to be a lot less work to type. So if we say A1, A2, and A3, that's going to give us, and let me move my face this way, that's going to give us, in this case, between 7, 8, and 3, the minimum is 3. Between 1, 2, and missing, the minimum is 1. Between 3, 3, and 4, it's 3. Missing 7 and 8, it's 7. 1, 7, and 1, it's 1. Now these functions will disregard missings. Whereas in R, you specifically have to specify whether you want to remove NAs or not. The min, the max, the mean functions will simply not take them into account. The very cool thing that SAS allows you to do. So for example, imagine that we had from A1 to A10, for example, and it wasn't as simple as typing A1, A2, A3. SAS has the of keyword at its disposal. And if you put the of keyword in a particular range, SAS will fill in the blanks for you. Or not the blanks, but the values in between. So for example, if you say A1-A3, it will fill in A2. If you had A1 to A10 and you changed this to of A1 to A10, it would just take into account also A2, A3, A4, A5, 6, 7, 8, and 9. And that's extremely useful, provided that you've got these easily inferable variable names. Now, if you don't have that, for example, I just want to see what happens if we try and do X to Z. I haven't tried that before, but I know there is a way of making it work. So in this case, it doesn't work because there's a missing numeric suffix, and it cannot infer what you want it to do. However, SAS has a very, very useful way of countering that, which is the double dash. And if you put a double dash in, it's not going to try and infer a particular number in between, but it is going to try and what it will do rather is it will go and look at the order things go in the PDV. And so if you specify X double dash Z, it will come to x in the PDV and take into account all the columns between x and z in the PDV. And so if you wanted to go across, for example, A1 to Z, you could simply specify A1 double dash Z. So the single one, you need a particular numeric suffix that SAS can make sense of. If you use double dash, it'll go from this in the PDV, take everything into account between A1 and Z, including, and it'll just use that without having to worry about a numeric suffix. So if, for example, we look at, so this is going to be still 3. I'm trying to look for an example where it would have had to take from X, Y, Z. Well, you'll have to take my word for it. It works. So if you use the double dash, it will just take the columns in between a starting and an end point. So A1 and Z, which we specified here. You can, of course, type it out. So the equivalent of this would be A1, A2, A3, X, Y, Z. And you will get the same result here. So that's how you would use the of keyword or not. If you wanted to do max, this is actually of all, not just of A. Max of all is max. And in this case, I'm lazy and I'm just going to type this. You could do the mean as well. And that gives you the min, the max, and the mean. Now again, bear in mind that this is all row-based, because the PDV only takes one row at a time when it's dealing with the data step. If you want to do things in a column-based fashion, you would have to use, for example, a proc means or a proc univariate or whatever the case may be. And we'll talk about proc means again in chapter 15. So I think we quickly looked at it in chapter 7 or episode 7, and we used it for spotting some data issues. But we'll look in episode 15, we'll look at proc means and proc frec in greater detail again. Now we understand how min and max works, and we have a mean here. The next function we can look at is the rounding function. Now in SAS, this works a little differently to what you might expect. So in R, you might say round something to 1 digit or 2 digits or whatever it might be. If you use the round function in SAS, I will move up there. If you use the round function in SAS, then it rounds to the nearest multiple of the second argument. So if you want to round to 1 decimal place, you would round to the nearest 0.1. If you wanted to round to the nearest second decimal place, you would round to the nearest 0.01. And so, for example, if you wanted to round to only a whole number, you could do something like the following. You can do this, or I think you can even just leave it out. So we have mean all calculated, but we know that mean all is a decimal format. I'll sit over there. If we round it, we should get a whole number in mean rounded, which we do. So 5355. If we then want to round to the nearest single decimal, we would use 0.1, which gives us 5.3, 3.3, 4.5, etc. And if we wanted the nearest second, if we wanted to 2 decimal places, we would round to the nearest 0.01. So this works a little differently than you might be used to, but if you've worked with SAS long enough, you get quite used to this. That's rounding, which I hope makes sense. Play around with it, practice, and it should start coming together for you pretty quickly. The nice thing is that you could, for example, round to like the nearest 0.2 or 0.5 or whatever it might be. So you you have quite a lot of play with this function. The next couple of functions are fairly straightforward. You can get the square root of a particular argument. The natural or base e log is just the log function. The base 10 log is the log 10 function. And exp is base. So if we say x equals exp of y, then it's going to be e to the power of y. And that's your numeric constant e, which is 2.1727. I can't remember. Well, we can find out. So let's say e equals exp of 1, and that's just going to give us the constant itself back, which is 2.71828. That's what it is, 271828. So that's your numeric constant. So if you say exp 10, for example, that's e to the power 10, which is 22,000 something or other. So that's your exponent function. Keep in mind, if you just wanted to get something to the power of another thing, so for example, we can say x is 10 to the power of 2, you would just do it like this. With a double asterisk, I think R uses the same. Some languages choose to use a caret, which is this character, but SAS uses the double asterisk for the power function. And I've overwritten x because we already have an x. Let's take that out. And we can replace our data set with what we had originally. Moving back to the slides, and we're going to start wrapping up fairly quickly. There's a couple of extra functions I want to look at. So the lag, the diff functions are two of them. So lag will return a value from a previous observation. The only thing to keep in mind is that lag will use memory to do this. So for example, if you've got a numeric value that is in the best 8 format, so it has 8 bytes that it has reserved for this number, if you lag that one record down, SAS needs to keep in memory the previous 8 bytes. If you lag up to 100, and I think the default is to 100, so I don't think you can do lag 101, but you can play around with this and you can see if that works. So if you lag 100, it needs to keep the last 100 numbers of length 8 bytes. In other words, it needs to reserve 800 bytes. Now, this all sounds very small in today's day and age, where some of your most basic laptops can come with 16 gigs of RAM. But the matter just to keep in mind is that you will be using extra memory when you use the lag function. And if you've got 1,000 different columns and you've got 1,000,000 rows, these things can start to add up. So let's take a quick look at how the lag function works. So we can do, for example, I'm just going to do x1 is lag. And so lag 1 and lag is the same thing. It'll just take the previous record. So it jumps up by 1. If we do x2 is lag 2 of x, and we do x3 is lag 3 of x. And keep in mind, you can go as far as 100, at least to my knowledge. So x1, so you can see x was 3 in this record, and we've pulled that down into the second one. Likewise, we had 7 here. That's now pulled down. So x1 is lag of x, so it'll go and look at the previous value of x. Likewise for 5 has jumped to there, and 2 has jumped to there. x2 is similar, so it jumps up 2 records and goes and fetch the value of x. x3 jumps up 3 records and fetches the value of x 3 records back. Now when we say it fetches it, it just has been carrying it forward in memory, because we know the data step and the PDV does something one row at a time, so it kind of pressed, you know, like the memory button on a calculator. It just has been keeping this value in memory for a while. Because we've got lag 3 here, and this is in the best 8 format, so 8 bytes reserved for 3 records at a time is 24 bytes in memory that we used for this one. And then here 16 and here 8. So 8 plus 16 is 24 plus another 24. That's 48 bytes. So we've used 48 bytes of memory to carry forward these numbers across, x across 3 different columns. Diff basically does the same thing as lag, except it works out the difference as well. So if you do lag of x, it will just carry forward the value of x. If you do diff, it will take whatever x is now and subtract the previous value of x. So 7 minus 3 will give you 4. And I'm just going to switch all the lags to diffs. And so you can do diff 2, diff 3, etc. up to diff 100 as well. And so 7 minus 3 gives us 4, 5 minus 7 gives us minus 2, 2 minus 5 gives us minus 3, and 9 minus 2 gives us 7. Likewise, if we go 2 back, so 5 minus 3 will give us 2, 2 minus 7 will give us minus 5, and 9 minus 5 will give us 4. Likewise, this just jumps back 3 and does the sum. So 2 minus 3 is minus 1, and 9 minus 7 is 2. So that's the lag and the diff functions explained. Just always remember the way that the PDV works so that you don't get confused and think that this is a way of doing things across the column. The data step always does things in a row-based manner because of the PDV. Something just to keep in mind is don't execute lag and diff in conditional statements, because the whole principle of saying, well, I'm at row 3 and I want the value of something that was in row 2 is the existence of row 2 as it was in the original data set that you were reading in. So as soon as you start filtering things and executing conditional, say if this then delete, or if this then output, or whatever you're doing, if you're removing or increasing rows in that data set, then you get to a point where this is no longer what you expect it to be. So first, do whatever conditional statements you need to do to be safe. Pipe that into a new data set. So, you know, this is step 1. You take that and you use that as input into data step 2, and then you use your lag or your diff function as is appropriate. Because otherwise you're going to just cause a lot of headaches for yourself. The COALESCE function returns the first non-missing value from a list of numeric arguments. There is a character equivalent that I should have mentioned probably in the previous episode on string functions. That's COALESCE. And the way that works, and the off keyword should work for COALESCE as well. I didn't put it in here, but we can take a look at it. The way that works is just to give a number of values to the COALESCE function. So let's say first non-miss is COALESCE of A1 to Z. And I hope this works. It does. So in this case, where our first one was missing, we got 7 as the first non-missing. So that basically takes all of those columns in order and returns the first non-missing value back to you. This is very useful if you've got, for example, multiple columns where only some of them are populated. So maybe you've got certain things, for example, in an adverse events data set, and maybe they're highlighting certain things. So they would say, okay, well, in this column, we're highlighting, is it a autoimmune event or not? And they will simply say autoimmune event. And then they would have another column to say, okay, this is, for example, a corneal toxicity event or something. And so you can kind of coalesce across all those different columns to just get one particular column which captures that event. And it's not the best way probably of mapping that data in the first place, but if you're presented with data that has been mapped like that, then you know how to handle it. Coalesced function extremely useful, because the alternative would have to be probably, would it be a bunch of if statements? If missing, then look at the next one, that sort of thing. Coalesce is your friend. Likewise, sum is pretty easy, so I'm not even going to go through that, because it will just within that row sum up all the different columns, and you can combine it with the of keyword. Keep in mind that coalesce also supports the of keyword. There's two more functions that we're going to look at. That's smallest and largest, and that's just the nth smallest non-missing value and the nth largest non-missing value. So if you have a bunch of columns, A1, A2, A3, then smallest will give you this. So if this is 1, it's the smallest function. If n is 2, it's the second smallest number, sorry, not function. And if n is 3, it is the third smallest number in this list. So we can take a look at that maybe. So let's just say smallest 1, and can we do an of keyword in here? Oh, I really hope so. Of A1 to Z. That works. So the smallest non-missing number in here is 3. The second smallest non-missing number in here is also 3. So SAS, I believe, takes into account the duplicates, and you will still get 3 if you ask for the second smallest non-missing number. So if we put in the third smallest non-missing number, we should get the number 4 in that first row at least, and we do. And likewise, we can switch this also to largest. So we can say, well, give us the second largest number in each row. And of course, that's the non-missing number. So if you've got missings in here, it's simply not going to take them into account. Second largest number, if we look at line 2, for example, we've got 1, 2, 3, and 7. 3 is indeed the second largest number in that particular line. So that's the smallest and largest functions. Again, you can combine them with the of keyword. So you would just do it as follows. You would say second largest, third largest, whatever, comma, and then you can put an of, or if you wanted to limit it to particular columns, you could do something like this as well. But that's a lot more typing than the other one. Bear in mind, if you have a numeric value in between, you would simply use the single dash. That about wraps it up for today. This was a shorter episode, but keep in mind that we've had episode 14a, 14b, 14c, so we've done quite a bit of legwork to get chapter 14 done. Chapter 14 is probably one of the most important chapters to know, not just for the base exam, but also for working with SAS on a day-to-day basis. So let's wrap this up for today. Chapter 14 is finally done and behind us. We've got chapters 15 and 16 left. And then I'm going to add chapter or episode 17, because there's two functions or two topics we need to look at which will be in the SAS base exam, but I don't believe they are covered by the base prep guide, at least not in the edition that I have. But we are almost at an end of the SAS base episodes. I would just like to thank you for watching this episode again, for tuning in, and I hope that you have found it useful. You're very welcome to like and to subscribe. You can leave a comment if I got anything wrong, or if you would like to add something to the conversation. But until we talk again, I will wish you a very good rest of your day, and have a productive SAS practice session. Cheers. Bye-bye.